Offline, online, offline, online, offline. Okay, I'm online. Oh, that's a bit bright, isn't it? Okay, welcome to part, I think it's part 4. I'm not sure. Here we go. Anyways, I need to look for my little thing. Beep. And we're doing this again. And, okay. So if we're doing that, yeah, I should probably make more of a timing on these and let people know in advance. But I kind of just feel like I just do it when I can be asked. I know it's quite, well, it's probably like 3 times a week, but I can't really plan a time. I'm just a bit, you know, just too old. It's too spontaneous. But, I mean, the good thing is you can watch these back. I'm going to have to ask if the videos last forever, or what's the duration on the playback videos. Because I think I'm getting quite a few people watching, yeah, the playbacks, but I'm not sure. What am I not sure of? Yeah, I'm not sure if it's... I don't know what I'm on about. I forgot. Oh, I need this thing. Just to know if I'm talking to myself or not. That's kind of like, you know, it gets a bit awkward. All widgets, view count, and then launch that. Yeah, then I get an indication of who's watching, which right now is no one. So right now, I'm strictly talking to myself. Never mind, can't win them all. Let's go into here. Okay, so we've got all this going. What's going on here? Oh, we ran the test suite, didn't we? What was wrong with the test suite? It all passed. Expected 42, but got num-p. It wanted A. Come on, that's a bit tight, isn't it? Closest to 0, 10 or 5. Expected 5. So examples, failures 2, errors. Oh well. Yeah. I don't know what that is. I won't fixate on that too much. Let me close some things down because they'll get in my way and then I'll end up going into them. Here we go. So hopefully the microphone's okay. I'm not sounding like a robot today. What else should I be checking? I think my Wi-Fi card's working. I mean, it's the sort of thing you say, don't you, when you're like you got a PC set up. My Wi-Fi card's not working. That's usually why I pay the extra premium for the old bloody Apple product. And they've royally screwed me this time. They've gone, ha, sucker. Okay, so what I'll also do is this. So we finally started chapter 2. And we went over a few bits. And this, oh, yeah, I've posted a link. You might see it on the right somewhere of the screen. If not, it's this. This guy. Here we go. Learn4haskell. I'll pop it in again. Because I think when you go straight onto a screen, or sorry, into the channel, it doesn't keep a history of... I think that's right. Yeah, when you refresh a page, like the history's gone. So yeah, that's what happens there. I was going to do this. Well, I've been doing this again, which is monad transformers, but probably not for now. I mean, I do know them, but I just wanted to go over them again, just to get. It's the thing with Haskell and things like this. You have to kind of go over concepts multiple times if you're not already a genius. Which is that's my area, the non-genius part. Yeah, so chapter 2 is going to kind of go through these bits and pieces. So is immutability, pattern matching recursion, parametric polymorphism, which I did go through the end yesterday. It's not as big as words, it seems. Lazy evaluation, higher order functions, partial function, application, and Eta reduction. That's basically make my code smaller, you know, like the actual lines. Partial functional application, that's kind of like, well, that's cool. That just means you're partially having a function, you're setting it up ready for another value to come in. Higher order functions, lazy evaluations. I've kind of been going over this already, what's happening with lazy evaluation. Parametric, that one. Recursion, which is like looping. Pattern matching, we've done some pattern matching already in the last one. Immutability, and a list of data types. So we read this stuff, went through the imports yesterday, so it's just to explain how imports work. It's a case of having import and then it's uppercases, and then you tend, and the example I gave is if you looked in another, on the left here, in another project, I've got a bunch of stuff, and so let's go into one of these. So if you look, it's actually inside lib core app monad, and then I've called this module lib core app monad, all of uppercases, and then it's, you have to have a tendency of this matching that name there, and then you can have these lowercase if you want, but I tend to have them all uppercase, so then you can just simply find your way around. So that's the naming of the modules, and then the imports is here. So you end up importing whatever it is. So say if I'm importing things that's related internally, because I've called everything lib, that's my internal stuff, and this stuff will be either libraries or you get something called base, which is like it's like another library, but it's the one that's built in, and then a lot of these will come from base. But in our example, in here, there's actually there is only base basically, and you get this file, which is used to set up your project. This is it's not. I mean, we can break it down. It's not too bad. Common options. Okay, so that's like the things that you're gonna use. You'll see it. Look, it's used there. Common options is reflected to that, and that's just saying I'm creating these different things, and they're going to use these common options. These here are compiler flags, so it's a specific thing that like the compiler uses. You can have them there, or you can have them in line, as in you can put these actually can go in specific files themselves. So that's pretty cool. This is like for handling certain versions of GHC, blah blah blah. Here's for the doc tests, so that's just saying go inside my test, this is a library doc test, and then whatever, do my stuff, import chapter 1, 2, 3, 4 inside of source, and do something else. And this is the one that we're, oh yeah, no, that's let me look, yeah, so this is the one for us. So we're literally where is the in common? I think it is. Yeah, here we go. So build depends on is like the libraries that you're bringing in, and in this case we're depending on this is base, and this base has got loads of stuff. And then the way to sort of check that is if we go on to Google. Over here we can search for sort. Let's say sort. There we go. So you see it's sort, and here's base. It's generally all this stuff is inside of base, and base is like you know, like the prelude, right? Yeah, it's prelude basically of everything. So you see, look, all this stuff you get, and you get more because this is in base, but that's data.list is in base, and there's just loads of stuff. So normally, if you just import base like we have, you'll get a load of stuff. So that's pretty cool. Yeah, and then we're on to here. So that's how you do imports, and you know how you're bringing in different libraries. And then Google's always a really good way to search for things. So you can always go here. I don't know. let's go traverse, for example. That's in base. Let's go, I don't know. Is there such a thing called loop? There is a loop. There we go. So you could say, I want this loop, and that comes from the library pipes. So you go loop. Well, you can go to loop. I could have pressed pipes. Yeah, and if you see here, or either, I think it's just here. Yeah, so it's called pipes. I ended up on the top right. This is another good one. If you go on the top right and you press content. If you press content, there we go. And then that'll take you. That's usually the name. So you see, look, in the URL. Then you're on Hackage. Just don't worry. But yeah, if you click that, and then you can go directly also to the GitHub repo, which is handy. You go poof, there you go, and then you're on a GitHub repo. Well, I'm on the issues, but there you go. That's pipes. Cool. So that's kind of like how you navigate your way around. You know, trying to find specific libraries if you're importing stuff. Okay, so list. Get shield. Shield list. List is a crucial data type in Haskell and functional programming in general. It represents a collection of elements of the same type. The list type is written as a type of list element in square brackets. So there we go. So when we declare a function like my list, for example, there we go. So if we do that, and then we want it to be a list. So say we can have like int. Okay, that's 1. And then we're going to return, or we're going to go on a new line. What is it? Oh my, you see that? I'm up there. Okay, I'm pressing enter. I'm going to press this. Okay, it works this time. I don't know what was going on. Yeah, so there, that's basically those little brackets is saying I'm going to return a list of ints. Okay, so that's what a list is. And then if you end up representing it, if you want to sort of like also, well, let's have a look at this. Let's do my list, for example. We'll take an X. Actually, we'll ignore the input. Okay, and then we're going to return. Oh, it's because I'm pressing the wrong button. My down key is next to my left square bracket. Best place for it. And here we go. That would work. You see, the compiler's not complaining. But if I was to, and another thing you need to keep, you know, about lists is they all have to be of the same type. So this, it won't be happy. You see, it couldn't match expected type int with actual type char because a string. Hold on, if I do it like this, it'll make a bit more sense. There we go. Yeah, so they've all got to be of the same type. Okay, so you can't mix them. There is ways of mixing them, but yeah, you tend not to when you're starting off. Don't mix them because it will just create more confusion. But in the long run, you can. There is like compiler. Well, I guess you could call it magic. Yeah, there's like compiler magic that allow you. Where am I here? Control X. Pew, there we go. Yeah, you can do it, but in a form, you know, when you're starting out, it's good practice to try and keep things of the same type. Yep. Okay, so that's what it's basically saying. You can have integers of bool. Sorry, a list of int, list of bool. I did read a little bit of this at the end yesterday, but I'll keep going. Oh, the other one that I wanted to demonstrate. So here I've got my REPL up. So, you know, it's like a little experimenting area. What you can do is if you go on the repo that I linked, it'll show you how to get set up, and it will show you also how to access the REPL. I've got mine built in to my Emacs. Well, I'm using Doom Emacs. So when you're in here, I want to show the type. So yeah, I shortcutted it, but if you do colon type, and then I can say like this, hello. So you kind of think that'd be okay. You'd think, well, it's also the type string. Okay, so that is actually the type of string, but a string, its representation is a list of char. So each one of these is a char. Okay, I can demonstrate how we know this is happening. If we go in here, we'll open up Hoogle. We'll look for the type string. Okay, there it is. There we go. Right there. String, type string equals a list of char. Okay, so that's how it's doing. So anytime you're playing with strings, really, you've already got a list. So yeah, if you've had to play before, that's what's happening. So let's go into that. To create a list, you need to put the elements in square brackets. Yep. We've done that. And we can do false and true. Without anything, you can have an empty list with obviously just the empty, the brackets and the thing empty. You probably noticed that the list could be of any type of any element. Often you want to write the function that works with list of any types, but consistency inside one list. So what that's okay. So this is going on a little bit about polymorphism over here. When you see in functions, if you see it like this, what it's essentially saying is, because you can make it concrete by going like this. This could be bool, and that'd have to be int. Okay, so let me just show you what it was like before for it to make a little bit more sense. Boop. And this was BV, and this again was A. Okay, so that's what it was before, but we've made it concrete to accept specifically these values. We're saying, okay, well, give us an int, a list of int, a list of bool. I'm going to return you a list of ints. And here it's saying, give us A, could be, whatever you want it to be. It could be here could be bool, and that could be list, and another type of type B, and then I'm going to return you the matching of A here. Okay, so you can do anything inside your function. Whatever you happen to be doing with two lists of different types, you can use that, and then you can return a list of the same type as the first type. Okay, so and then that's saying that this function then becomes polymorphic, because polymorphism is basically saying I'm allowing the freedom. I'm allowing my types to have the freedom to be of selected types, but I'm still being slightly restrictive, or I'm being as loose as possible is probably a better term, by demonstrating that I'm going to take some ints in, and you'll see it again here. I'm going to give out some ints, and then I'm also going to take in some bools. So when you see sort of like polymorphism, you think, oh my god, it's such a crazy word, but really it's not that bad. The word is, yeah, but the concept isn't that bad. So I've explained that a little bit. Let's have a little. The above type signature means that this function takes two lists, one with the element type A. Yeah, so we've sort of said. Yeah, okay. So they become type variables. Is that what I just said there? And returns the list of the elements of the same type in the first list. Such words A and B are called type variables. Yeah. So you're just representing a type by just saying this stuff basically. And then you can concrete it once. Well, you can leave it like this, but I'm just showing this representation. So for comparison, specific types in Haskell start with the uppercase letter. Yep, so we know that. When types variables begin with lowercase, this is a way to distinguish between these types. Yep, so that's from there to there. The Haskell standard library already provides a lot of functions to work with lists, and you will need to operate a lot with standard functions in the upcoming exercises. Remember, Hoogle is your friend. Yes, that's where's our mate? There's Hoogle. That's our friend. Let's have a look. So, task 1. Explore list by checking the type of various list expression and functions in GHCI, which is our REPL. So it's here. Obviously that's shown like that, but mine's got like a little symbol, which is a lambda. But that'll be explaining. So we'll do T, which is for type. So we're trying to find out the type of true or try. and false. And that's going to be, so it's going to show you true and false. And as you remember, it's much like in a type declaration. So if we go back up here, like these two means ba 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 is the type of. So here it's saying ba 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 is the type of list of bool. Okay, so that's that one. This one, well, we kind of just, I showed you that a second ago, but I'll do that again. What do they say? Some string. And that was the interesting one, because a string is actually a list of char. Okay, so we talked about that a little bit. This one. Let's have a little look. Boom. That's just, there we go. So it's assigned it to a polymorphic value, because it doesn't really know. You've not at any means, but if I was to do, say, let's do this. We can like cheat. Oh. Oh. Oh no, I can't do it like that. Oh no, it'd have to be inside. Okay, yeah, I can't do it like that. Let's just do this again. Type of that. Yep. So that's just saying it's a list of A, because we haven't declared what the values are being here. So it's polymorphic. It's open to be whatever we want. We're telling the compiler, I don't know what it is yet. It's a list of something. Okay, append to lists. Okay, so you can do like this. Let's have a type of, so it's just going like that, plus plus. So you see plus plus. So you know when you do, here we go. We'll look at a simple one, which is plus itself. Oh, I was like, what have I done wrong? Why is plus not? I was like, plus isn't there? Here we go. So let's compare them. So we've got plus is just A, and A, which is constrained. This is what this little bit with the fat arrow is saying. Constrain my A's. You've got a way to, be a little. So you can literally leave things with just A and not have this. Or in this example, we're saying, well, the A's are going to be of the class num. So classes, you can sort of think of them as in Haskell anyway. As so when you look at int, that's part of the class num, okay, and double and things like that. So these essentially we're saying, well, it's still not fully concrete, so we're not saying it's an int, but what we're saying, it could be something of the class num. Okay, so we could use those. And this one at the moment, the plus plus, it's purely, it's really like polymorphic here. It's just saying it can be A. So it can be anything. Anything, takes anything again, and returns anything. So let's try that. But notice it's definitely of the same type, because they're using A, aren't they? So you like A. It's not, you can't use it like this. You can't go true, true bool, true false, because then I'm going to show you, you'll get an error. And then if I do 1, 2, 3, yeah, it will say that, well, basically instances we'll go into later, but it's just saying I can't find an instance of num and bool. So there's the num, okay, and it's saying, well, these are nums, these are bools. I can't add them two together, basically. But on the flip side, if you end up going 1, 2, 3, and then 1, 2, 3, there we go. You get back. So they literally just, they patch onto each other. So it'll go like 1, 2, 3, 1, 2, 3. You see, so it's literally going like that, and it's append. So it's appending these values to the end of these ones. So if I demonstrate it in another way, which would be 1, 3, plus plus, what am I doing? 4, 5, 6. Okay, and then you'll see it. 1, 2, 3, 4, 5, 6. Cool, that's what they are. This one, so we've seen a double when we sort of declare functions and in a type definition, which is up here. So we've named a function and we're going to give it a type. We get 2. But if you have 1, it's a totally different thing, and you can't use it in a type declaration. This is within the body of a function you use these, and that's prepend. So well, first we'll look at what they want us to do, which is prepend. So we'll do a bit of that. Okay, so it's saying this is slightly different. So the type before of append, it was saying it's AAA with all list, a list. Okay, in this scenario it's saying our first value is of A, and we give it a list of A, and we return a list of A. Okay, so let's try it. This is our A, then we're gonna that, and then we've got to give it a list. So 1, 2, 3. Let's have a look. Aha, so prepend, as in the name, append would be at the end. Prepend with 1 value puts it at the front of the list. Okay, do you see how it's done that? So if I do, yeah, I mean, that's quite obvious, I think. So 3 is added at the beginning. Okay, so that's prepend. Prepend an element, and I think that's called cons. Let's have a look. Like that. Where are we? Oh. Why are you not finding it? That's a bit weird, isn't it? Like that? No, you've got to find it. Anyway, yeah. It's on there. Doesn't matter. So, reverse. That's another one. Let's have a look. Type. Reverse. Let's have a look. So, that takes a list. And, I mean, you know, the name should be fairly obvious what it's going to do. You'd think so, anyway. We're going to reverse that. So 1, 2, 3 is going to become 3, 2, 1. Yeah, that makes sense. Take. Take we ended up using that at the end of the last lesson. Or sorry, that's the end of chapter 1 we used take. But let's just demonstrate it. So take the type. Okay, so it takes an integer, a list of any A's, and it returns us a list of any A's. So how does this work? We're going to do take 1. Okay, we'll try it with a list of ints first. Right, so that returns us 1. Let's do take 2. And then we'll do 1, 2, 3. And that will return us 1 and 2. So you can you see the pattern? It's just basically say take X amount of elements from my list. So we started with 1, and obviously take 1 returns us. Oh, I should demonstrate that this stuff is just like a warning. The results are down here in case you keep seeing it. Oh, I should have mentioned that before. Oh well, never mind. You know now. Yeah, so there's the result. So take 1 returned us 1 when we gave it a list of 1, 2, 3, and take 2 returns us 1 and 2. So that's how take works. And then again, that'll work with any A. So it doesn't have to be a list of numbers. We can do take 3 of true, false, true, dot, false. There we go. So it'll return us true, false, true. Okay, so it will knock off the last one. Well, it doesn't knock off the last one. It actually takes the first 3. Okay, so that's that. Replicate. I mean, I think you can imagine what that means. Replicate, it takes an integer, an A, and then it returns us a list of A. So, I mean, you'd imagine that you're going to replicate. If it's got an int, you'd think probably a number of times. And if we pass it a 2, so we're going to replicate 4 times the integer 2. Yeah, see results 2, 2, 2, 2, 2. So let's do, let's replicate 4 times, and now we're going to go true. There we go. So that's kind of like demonstrating, again, the polymorphism of this function. You know, you can see that replicate works for all these different types, and they're not even in the same class. You know, because like I've done bools, I've done integers, which is num, and now I'm about to do chars, or a list of chars. See? So yeah, so when we looked at the type of replicate, oops, we looked at that, you see it's A. Okay, so we're just saying it can be anything, but as long as they're matching. Because you can see, look, that's the type that we put in. That was our A, and here's our A. It's returned us a list of A. So it's not changing to like a list of, you know, like Z's or whatever, you know, because you can see in the type that there's A and A. So it's always got to be the same types. And the same happened here when I did trues. Yeah, it goes true, 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 true. And I passed it. So that was the type true was our A. Sorry, it would have been bool. And it returned us 4 bools. Okay, lines. So look what this does. T lines. Okay, so it takes a string and it returns us a list of string. Okay, so let's do lines. And hello there. I mean, this won't be exciting. Okay, so that returns us that. Now let's try it like this. Well, you can see we've literally done a string and then it's just wrapped the string around in a list. Let's do it as that because it needs to be a string. So oh, I like it when you do that. Thanks. I guess. Oh, is it the other way around? Hold on. I can't remember how you is it that way? There we go. Okay, so that's like in Haskell when you want to define a line break. So this would be like a new line. This character you'll see it. Do you see how it got ignored? And it just takes a new line. So it's just basically saying. Hold on. It's basically saying. Whoops. It's basically saying this. But this will fail because I've actually gone on to 2 lines. Probably not the best. Yeah, there we go. So, what the hell? You're on to 2 lines. But that represents that. So essentially lines looks for this line break and then it will return you, you know, like, well, can you even see it's like literally it's broken on there and it's even returned the little bits in. So there's like a space there and a space there. So we've given it a string with line breaks inside and it's going to return us lines. Okay, and then unlines. Whoops. Oh, we'll do the type. Unlines. So that takes a list of string and it will give us back a string. Okay, so we can do that by... Oh, I love it when this happens. I shut down my email and then it just opens up on itself. Honestly, OS X, what a product. I've been with it for like, God, over 20 years I've been using Macs and things like, you know, before it was even a thing to have a Mac as a developer. And yeah, what a nightmare. They've gotten a lot worse, I can, you know, say. So we're gonna copy what it returned us before. So if we go back up here, here we go. We're going to cheat. So hopefully that should return us this. So if we do unlines, cool. I don't know if I wanted all that stuff, but I'll have this. There we go. It's done exactly the same. Hello there, and it's put in. Oh, it's even put one at the end. Thanks. So I guess it's saying that that's the end of a line too. Cool. Okay, task 2. So that's task 1. Nice, nice. To understand a list type better, it is also beneficial to play with the list expression in the REPL, which is what we've been doing. So we've actually done this. I mean, yeah, we saw exactly what was going on. Actually, we just went through all of these, didn't we? 10, 2, 3, 15. Yes. Oh, these are interesting ones. Yep, so we did that. So that's basically an empty list, append an empty list to 1 and 4. I mean, let's try it. But I'd assume it's pretty obvious what's going to happen. Yep, it'll just, because it's an empty list, so I'm just add nothing to 1 and 4. You know, append 1 and, yeah, so you're just going to get 1 and 4. So prepend there, 3. So we did that. So that would return us 3, 1, 2. There you go, 3, 1, 2. That's what it's returned us. This one, oh yeah, you can like stack them along. So essentially, what it's saying is, if you wanted to think of it, you know, because sometimes that might be a bit confused. Like, well, you can just, but really, what's going on is this as well. You know, just to make it look well, you don't even need the external one. Yeah, it's saying the result of that, you know, because we know that when we run prepend, yep, that we get a list of something. So then we'd get another list, which would be 2, 5, and 10. And then we're going to put prepend 4 at the beginning of that. So it'd be 4, 2, 5, and 10. Hey, Gil Christian, how's it going? He's got the octopus. Nice to see you. I'm still working through chapter 2, and we're going on fires, lists, and we're just going through variations of lists and prepending and appending and things like that. So yeah, good that you're good. Good. Let's take this off. Just there we go. So, well, I kind of said what would happen, but it's 4, 2, 5, and 10. Cool. So that's happening. Now, what is going on with this? This looks like a bit of magic. This is really useful. If you're lazy, which, you know, let's be honest, I am. 1.10. What do you think is going to happen here? Get ready. Boom. 1, and it'll go all the way through to 10. That's pretty handy, isn't it? So if you want to, I don't know, if you happen to want to go through a list and you want, you know, it to start from, oh, I wonder what happens. Actually, I've not tried this. Let's try this. A to, I don't know if it's going to work. Z. Boom. There you go. It works for that too. So if you want, that's gone through the whole of the alphabet. Pretty handy, isn't it? Yeah, so that's a list range. And 10 to 1. So you can go backwards. It's clever. Oh no, it's not that clever. That. Oh, okay. So 10 to 1 is not good enough for it to work out because it's going. What do you mean 10 to 1? But if you go 10 and you're saying like what you're giving it the range of what it's going to, so it'll go down. It'll decrement. Yeah, it'll decrement by 1. So if I do 10, 9, 1, you see, look, 10, 9, 8. But if I was to do 10, watch this, this is cool. So 8, ... That's definitely not a dot. Where's my dot gone? Yeah, and it gets rid of that. Oh, I love my keyboard. It's a combination of keyboard and IDE. There we go. So look, I've done it 10, 8. So it's gone 10, 8, 6, 4, 2, and it can't go to 1, obviously. So it's gone down in twos. And you can do the same going the other way. So you can go like 1, 4, ... and we'll go like to 80. There we go. And it's going up in 4s. 1, 4, 7. Oh, it's going up in 3s. It'd have to, yeah, the increment amount is 3, not 4. Okay, my bad. So it'd stop at 79. Yeah, so that's pretty handy. Length. Oh, this is a cool one. So you can literally, well, we'll do, actually I'll throw you first by doing length. Look at this. 3. A length of string. Because you remember string, that's a list of char. So you can see how many characters are in your string. Or if we use their example, we can do, where was their example? Here we go, yep. I don't know. Let's go 8. And that's free. Okay. I need to turn these interactive warnings off. What was it? What is the... Is it set? I think it's set. Set. Or is it that way? Yes, maybe it's this way. Set. Like that. And then let's go do this again. Hopefully that'll get rid of those warnings. Maybe it won't. No, it won't. Thanks. Thanks. You think that's how you get rid of it? Or is it just set like this? I'm pretty sure it's set. We'll try again. Some flags have not been recognized. Okay, no, it's okay. Well, that was right. I did use the right flag. But yeah, for some reason, it wasn't happy. It still hasn't done it. Yeah, well, whatever. It's free. We'll just have to look at the bottom and ignore. I think it's only an issue if we go up when things start being different colours. Yeah, that's when it becomes an issue. So if we go further up, there we go. Look, so that's when things and actual errors. When it's green, it's just a warning, which we can happily ignore. What do we do? Did length replicate? We've done that, which obviously it just replicates that 5 times, and returns us a list of true 5. Take 5. We showed that because obviously it's a string, list of chars. It will do 1, 2, 3, 4, 5. So let's just have a little example. Hello. There we go. Drop 5. Oh, we didn't see drop though, did we? Let's have a look at the type of drop. Type of drop. It takes an int, a list, and returns us a list of A. So let's have a look. What do you reckon is going to happen here? I think you should get it. It's going to be boom, world. Well, actually, it's a bit more. So we're dropping the first 5. Okay, so when we take, and when we drop, we say goodbye, and then return us the rest. So you see it's actually stopped. So 1, 2, 3, 4, 5, and then it returns us that, which is what happens there. There we go. Nice. Zip. Okay, what's happening with zip? So it's let's have a look at type of zip. Type zip. So it can be of any type A and any type B, and it will return us a list of a tuple of A and B. So if you remember, this is a tuple. Whoops, that's definitely not a tuple. So we can have hello, and we can have 2. Okay, which is not the same when we do it like this. Before tuple, that was okay. After, not okay, because lists have to be of the same type. Tuples, fine. And I know you might be wondering, well, if I want a list of anything inside of it, well, I might as well just use tuples and just YOLO it and have like tuples that are 10,000, the content of them is like, say, 20. Yeah, it might seem good at first, but what that ends up meaning is if you ever do type declarations, you have to follow your 10 types. So this would be like AB's BC blah 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 to whatever. Well, even if you're concreting, so it's not a good idea. The rule of thumb is once you've gone past 3, you need to start contemplating how you're making your stuff. But I don't know if we'll go through that in this chapter. Hopefully, but I won't go ahead because there's ways around that. But just remember, tuple. I think realistically, I sort of think past 2 because I think tuple 2. Once I've gone past 2, I'm like, yeah, maybe I should change it. But let's test zip out. Okay, so zip was a list of A, a list of B, returns us a list of A and B in a tuple. So we can do that. We'll do a list of A. Oh, actually, we need to run a call zip first. And we'll have our list of A. So 1, 2, 3, 4. And then we'll have our list of B, which will be A. I'll show you 2 examples in a minute because it does something quite clever. B and C. Okay, so right here you can see, cool. So that's returned just a list of, 1A, 2B, 3Z. So it's like zipping. You can imagine like a zipper, and each. Oh, I can't see if I'm looking at the right bit of my camera. I'm just guessing. Yeah, so each tooth is like an element inside that list, and it's going join them together, join them together, join them together, join them together. So you kind of like get a little ladder, and at each joint, once they intersect each other, so like it'll be like 1, okay, A, 2, okay, B. But what if this is the other bit I was going to show. What if this is the issue? What do you reckon is going to happen here? Boom. Okay, it's going to stop at B because there's no more, so it can only zip up to 2. Okay, because there's only B. What if, actually kind of did that, but I didn't demonstrate yet. And what if we I don't know, go the other way? So we'll go C, and this way we'll say there's just 2. There we go. So whichever one's longest, whichever one's the shortest is the length of the list that you're going to get returned, because it can't just make up, it can't just go, well, so in this scenario over, don't scroll so much, here we go. In this scenario, the first list was shorter, so your length is it's only ever going to be 2. It's going to ignore the third one, the zipping together, because much like an actual, zipper or in your jacket or wherever, jumper, if it's got odd teeth, it's going to break. So instead of like just going, I'm odd, it's going to go, I'm going to stop at 2. Thank you very much. And then it'll do the same if the shorter one is the list on the right. Yeah, so here it'll go, I'm going to stop at B. So goodbye 3 and 4. I can only zip up to B. Anything after that, see ya. So yeah, that's what happens. Words. Aha. This is cool. So, okay, so we've got like a sentence. I mean, we don't actually need it to be that dramatic. We'll go like this. Okay, we'll go like that. And words, actually, before I do that, I did press that one. I'll just delete it. We'll get the type. There we go. So words takes a string and it returns us a list of string. So if you remember, we did lines. That took a string and returned us, but it had to be separated by is that way, isn't it? N. New line. Okay. Well, this is the same, but it's going to look for spaces. So like a blank space. Yeah, you see, so it's going hello, and then so it's a list now. So we gave it a. Well, this is where the string gets confusing because I know I'm sort of ramming home multiple concepts. Well, not multiple, the same concept, and I keep repeating it, but it's just so you remember. The fact that that strings is a list of char. So this is a list, a string, which is a list of chars, okay, and then it's looking for the char of empty. Well, not empty, like a empty character. Don't use the word empty. That's confusing. I forgot what it would be. What do I call them? Blank space. Yeah, space. It's just a space. And then it's looking for that as the delimiter, as in, what it's going to split by. So it's going to take this string, list of char, and it's going to return us a list of chars or a list of strings. Okay. So you can clearly say it's just gone split there. Let's get these. Sweet. So we get all them. So that's how that one word works. Split a string into a list of words. There we go. Or just follow that. Haskell has a lot of syntax sugar. Yeah, so one of when they say syntax sugar, that's very much the syntax sugar of Don't do that. No, of course I can't do that. What's the thing? What's the thing? I think it's I can't remember. There's a way to see what is it. H? Oh my god! Oh my goodness! That's a bit too much, isn't it? Set. Print. Type. Doc. Edit. Oh, I can't see it. What's it called? There's something in here. Okay, forgotten it. But there's a way to show you that string is actually a list of char. Well, we can just go over here. We can cheat. We could just do this. Okay, so the type string is a list of char. So that's syntactic sugar, technically. It's kind of not, but it is. You know, you every time you see string, it's like, oh, well, that means a list of char. That's pretty handy. So, so what's this one? Okay, so the list syntax sugar. In the case with list, any list literal like 3, 1, 2 is syntax sugar for prepending elements. Well, this is a bit weird, isn't it, when you look at it? So you're prepending elements. So it's gonna put. Okay, so let's do this. We're going to get 3 and we're going to put it into an empty list. Okay? That returns us 3. Okay, so we're going to take 3 and we're going to take 2 and we're going to prepend that into an empty list. 3, 2. So you can kind of see what it's doing. So we explained it before. Why is that there? Because if we look at the type, and we were to do this, okay, so it sees, it takes a value, a list of something, and returns us a list of something. Sorry, an A, list of A, and returns a list of A. Okay, so why? Because if you look at the type signature, it's going, well, there's the first value I expect, there's a second. So if we were to do it like this, let's do 1 and 2, 3. There we go. That also works, but what it's also got another option called infix. We did explain it. A lot of examples will have it in ticks like that, and then the name of the function inside. But in this scenario, you can because it's something on base, you can put it there, and the left-hand side is the first value, and the right-hand side is the second value. And then because of the way it's, the way it puts these together, it's basically saying, I'll show you. Hold on. 2, 3. Let me just put like a few more together. Here we go. What it was doing is I was demonstrating before is this. There. And then there. Okay, so you see, watch this, right? So that's going into there. Okay, so that'd be like, let's imagine that's done that. So we're imagining. There we go. And then now we're doing that one into that one. Okay, so we're going to imagine some more. And then at this point, we've got this, and we're going to that one. Prepend that into here. Boop. Okay, so that's basically what it's doing. And I'll press that, and it's just going to return us that. So don't forget, the lists are the containers of the same type. Yep, meaning you can't combine lists of different types. Yep, we got away with it in zip, because if we look at the type of zip, it returned us a tuple. So it's a list of 2 values. But if that was A and let's do A and B, then there's no way. Well, yeah, on the inside, there's no way. You'd have to do something that would make sure it either returns one or the other. Okay. Don't forget that lists contain the same types, meaning you can't combine lists of different types. Oh, this is another example. 1, 2, 3. Okay, and then we've seen this one. And we'll do A. I don't know, B. Actually, because it's a string, we use 2. No, can't do that. Whoa, it's gone too far. Yep, it's basically no instance of num char, list of char. So sometimes you'll end up learning what these errors mean. I mean, to be honest, when you see an error, you can kind of see, okay, well, a list of char which is string. So there's no instance. I haven't explained instances yet, but it's just saying, well, num we know it's definitely to do with numbers and integers and things like that. And this is to do with characters. So, you know, there's no, the class num, in it, there's no string. So, if you want to if you want to see that, we can go into char. We'll go there. And then instances. Okay, so there's our data char. Here's our instances. Actually, I'll zoom in because it might not be viewable. Zoom. There we go. So, yeah, data char, instances. So we've got a bounded, we've got an enum, we've got an EQ, we've got data, ord, read, show, of all these chars. Oh, it's going the wrong way. Okay, but there's still instances anyway. But what we don't have, if we look here, we'd have to look at num. Let's go back. I've looked at the wrong one. Let's go to num with a capital. Different, remember. Class num A. Here we go. Let's go class num A, and where are they? Instances. There we go. Double, float, int, blah 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 blah, and the list goes on. And then if we'll go under S. There's definitely no string. There's no string in there. So we can't. You know, there's nothing that tells us how strings and nums interact with each other. They just can't. So it's just going, I can't do it. Sorry. Which is kind of like what they say. They're explaining the error? No, they're kind of saying. They're just showing us the error. Yeah. So couldn't match type char with bool. Oh, we get a slightly different error there. Look at them. Why don't we get that? So look. Ours is a bit more. No, they got it there. Didn't get it in the other one though, did we? Well, for some reason. Fair enough, they got a better one. So couldn't match type char with bool. And it's the list of bool. Yeah, so it expected a list of bool, but you gave it a list of char. And that happened when it's taken, so it knows the first value is going to be a list of bool. And which, let's go like this. What are we doing? Yes, like that. Cool. It knows our first A is going to be bool, but then our second A has also got a bit of bool, and then it looks at our second A and it's like, well, actually it's string, and then the error comes out is I couldn't match char because string. This is a list of char, isn't it? Yeah, that makes it a bit confusing. You know what I'll do? I'm going to make it so it makes slightly more sense. Not much, but slightly. Ah, it's too many. No, there's not. Yes, there is. No, there's not. Yeah, there we go. I'm not going to put commas in there. Oh, I should have just done it for 2 letters, shouldn't I? But whatever. Because we know that string basically means that. No, don't go up. Oh, I wish my arrows were in different places. There. We should get... Whoa. Okay, we'll get the same error for every instance. But there we go. Match expected type bool and actual type char. So it's going, my first A is of the type bool. My second A, because they're matching, should be also of type bool. But no, we're giving it char. So match expected type bool, but actual type is char. So if you kind of like remember how this reads, that's a good one to handle with like the type error. Because what you've got to do is when you're learning Haskell, be friends with the compiler. Don't, because I think for like a good year, if not more, I got annoyed with it. I was just like, ugh, God, I've got another error. You know, what's going on? And I'm the first to admit it, that the error messages aren't necessarily the best things on earth in the Haskell compiler. But when it's simple things like this, the main one you end up looking at is kind of this scenario, you know, what I couldn't match a bool, you know, I couldn't match the expected type bool, so that's what the compiler expected, a bool, with the actual type. This is what we gave it, which is a char. So it's like, I wanted a bool, you gave me a char, what's going on? Suck up, basically. So that's our error. Immutability. So yeah, we're on to the next point. Immutability. So again, potentially a big word, but I don't know, I think it's been thrown around in all sorts of places. Especially like, I know when I sort of stopped doing as much JavaScript, but that was definitely a big thing. If you think of immutability with, especially in things like React, and is it Redux, isn't it? Yeah, Redux, it stores, they're immutable. But let's go through it anyway. At this point in our training, you need to learn that all values in Haskell are immutable. And I mean, that's like all. So basically, you can't just change a value inside something. What's the best way? Mutability. You can't do this, basically. You can't just... We can't have just a value A, okay, that equals... Right? Anytime we do anything... So if we say... okay, let's do this. Yeah, okay. So let's do B equals... Watch this. This is pretty cool. 1... we'll do 4, 5, 6. Okay, and we do A plus plus. Okay, so we're do that. A is that plus plus that, and that's going to be our B. Cool. Now let's have a look at B. B is 1, 2, 3, 4, 5, 6. Okay, but because A is immutable, so technically here we've kind of like, you know, we've created a new thing. You know, well, we can even do it like this. We can even put it here. Okay. A doesn't change. You can only create new values. So whatever it was originally is never going to change. It's immutable. You can only create new values. Which at first seems like, oh, well, that's going to take up a load of stuff, but it's not. It's really handy. Hopefully it'll explain. They'll have more reasoning than me. Haskell immutable, woohoo! Well, apparently woohoo. But what does it mean for us? It means that when we apply a function to some variable, the value is not changed. Instead, you create a new value each time. Yeah, that's basically exactly what I said in a more condensed, nicer way. So it's not in a prelude, this one. We have to import it. We can do imports inside of the REPL. We'll do that. So we're importing data.list. Actually, let's have a little quick look whilst we're here. We can also search for that on Google. Data.list. Look at that. You can even search for that. So when you're importing things, data.list. There you go. So this is in base. When we did that, when we did this inside of here, the library, where was it? Base. There it is. Base in your face. Oh, sorry, bars. I call it base. I probably shouldn't call it base, really. Anyway, get rid of that. Go onto here. Let's demonstrate. And inside base, there's a section which is data.list. Okay, so when you do import data.list, and you get all this stuff. All these functions are inside data.list, which when we were in a REPL in here, that didn't exist. Okay, so now when we've done the import, we've got access to all this stuff. Look at that, all that lovely stuff. Okay, actually the stuff you'll find as the functions inside base are a little nicer. They're still, I still wish they had more, because I think what's lacking in Haskell is a lot of, because of its origin, a lot of people think that this is intuitive enough to explain what it does. And I mean, it does, you know, it's saying it's a list of A and it returns us an A, a single A. But if you're not from Haskell, it'd be really nice to have an example of head in action. So what I'll do is I'll show you head in action. Okay, so we'll do head of 1, 2, 3. 1. Okay, so that I mean, you know, they could have literally written this. And then you'd be like, hey, Commander Frushlin? How's Haskell? It's all right, you know. I mean, I've been doing it for quite a while, but I'm just trying to give tips on, you know, like make it just a little bit more approachable, because it is like it's a fun language for sure, and it's not too bad. What else was I going to say? I'm going to go back to here. I'll pop this in case people were missing it, but we're doing this, and you can do it as well. It's like a repo, and I'm just following. If you want to do Hacktoberfest as well, whatever, you fork this repo, put it, you know, wherever you want to keep it. Are you into like non-mainstream languages? No, not well. I guess Haskell is a non-mainstream. I think I was more attracted. Hold on, I'll explain in a second. I'm just going to show this quickly first. Yes, if you fork this repo and you can work inside of source, there's all these different chapters. So you can, you know, you work through them. We're on chapter 2 at the minute, and then what you can do is that each chapter, once you've done it, you create a PR on your own repo, and you can at either of these two inside your PR, and they'll come and review it for you and like help you, you know, if you've got mistakes and stuff. Amazing. So that's like a really nice way to do things. So yeah, that's what we're going through. I'm not going to PR them because it would be a bit pointless, but yeah, so that's what we're doing there. And now I'm going to answer your question. Are you into like, I guess I am with Haskell. Yeah, it's not very mainstream. It's certainly gone up since I was doing it. I've been doing it now for, it's come up to 4 years. I've been doing FP, pure functional stuff. Oh, is it really non-mainstream? Well, hold on. I'll finish with my little bit. Yeah, it can. I mean, it is in a way. It's definitely, what I was going to say is getting a lot more popular, like for sure. People are recognizing its benefits, and it is more widely used, like for sure. It's not, you know, we're not thinking of like a Java or a JavaScript, or, you know, it's not that big. You know, it's not as adopted that well. But it's certainly coming up and up in especially in production. Like I've seen it more and more, and as even like as for me when I'm looking for work, it's there. Why I don't necessarily think personally, it's not necessarily like a niche sort of thing is, or why I was attracted to it, is just the functional aspects of it. You know, doing things in a functional way is. It's like you think of problems differently, and they almost like become a bit more fun, to be honest. Like actual coding, yeah, it's kind of weird because Haskell can be seen, especially when you got like a type system that's as strong as Haskell's, or the other language I actually started was PureScript because I come from JavaScript. I'm going to try and catch up. Yeah, guess Java and C++, or like would call them mainstream. Yep. So is it being mainstream the same as being popular? Extremely close. Maybe not the same. Okay then, I guess the answer might be yes. You took it. Well done, Nideco. You took it. I mean, it's correct, you know. Commander. Thrashed in. My friend, he's called Ashmore, and he calls himself Thrashmore. So, yeah, I can relate to that name. Oh, you've been doing it for 5 years. Cool. It's alright, isn't it? I mean, for me personally, what really attracted me to it is it's hard. Does it need... No, okay. It's kind of hard, but not, because there is still an element of slightly gatekeeping, and it's not really gatekeeping. It's more to do with the fact that as a language, it's an academic language. So meaning that it's surrounding in academia, and what that means is its uses wasn't necessarily based on production. So therefore, which is primarily what I was showing here, with, you know, you get a lot of, well, you know, you should understand that. O1 extracts the first element of a list, blah, blah, blah. I mean, I guess that explanation is not too bad. but it's nice, you don't get things which makes it super user friendly, beginner friendly, sorry. That is changing. I mean, goodness, yeah. If we just look at this repo and the fact that this exists and people, they're willing to sort of help people out to learn it. And, I've done like some stuff on YouTube before. I did a course on eggheads for learning functional programming using PureScript. So I mean, it's, and what I want to iterate is I'm not a mathematician. I'm by no means mega intelligent. Like, I've got no degree in maths. I did high school for me in the UK and I got D, but yeah, I'm doing category theory but it doesn't have to be that, you don't have to think like, oh, I'm doing category theory, I'm better than you. It's just, repetition. Once you repeat stuff, and what I've enjoyed with Haskell is the niceties it gives me, like especially the compiler. I end up using the compiler as my little friend, and the compiler, instead of seeing it as like, oh, it keeps complaining at me, I've got things wrong, you end up using it in such a way with things especially called typed holes, where it can help you to predict what you're writing, what should go there and what should it be, especially when you've got like plugins. Let's have a look at something. Where's there a function somewhere? Let's create a function in here. Let's go hello is of type int to int, okay, and then I'll do hello equals I don't know, what should we do? Let's do this. Okay, we'll do all this. Okay, I mean, this is like really silly. Okay, let's have two things. Found a hole, okay, of T0. What are we doing? A. Okay, so let's expand this error. What's it doing? Found a hole. So it's saying it's found a hole. This is a hole, the underscore. This is a compiler, just give me all these little things. And it's going, okay, well, A over here is of the type int. Okay, so that's cool. And up here, couldn't match the expected type. Actual type. Oh, okay, hold on. I should do that first, and then we'll get some better error stuff. Here we go. Actual type int. A is applied to 2 arguments. Okay, whatever. But in essence, you can end up using. Can I do that? No, I can't do that. That's probably why. Let's do this. Let's do this. We literally just did it, so that's cool. Oh, that's because I did it. Yeah. Sorry, that's my fault. I'll show why I got that wrong. Okay, so we've got that. Okay, let's do this. Okay, now we can hover over that, and if you look on the top right over here, see I've got the types. So I know that function takes an int, a list of integers, and returns us a list of integers. Okay, so that's really useful. Okay, so I know what that function is. I don't have to go into wherever and try and find out. I've got it, as part of this plugin. But that I can get that from the compiler. I can literally question it. Oh no, I've lost it. Okay, secondly, type holes. Okay, and it's saying I found a hole that is int. So if we look down here, found a hole, and it should be of the value int. Okay, so you're like, okay, well I know in there needs to be something of int, and then it goes the valid. Okay, so what you've got, what bindings or what have you got in scope that what are they? What are their values? So you've got an A, which is our A there, and that value is of int. Okay, you've got a hello, which is our function, and that value is of int to a list of int. Okay, and it goes valid hole, and you'll see it say A. Okay, and it'll give you a bunch of other stuff, but essentially we know from just looking at that and just questioning the compiler that A is going to be a good solution, and not when you do when you do it like that. So yeah, that's the things. And you just couldn't, I guess TypeScript you can get fairly close, but you couldn't get like that. Do you know what I mean? And then this is like the basics, but then the type system can really expand. So I've got to catch up. Sorry guys, I got carried away. Where was I? Oh my goodness, you've been going on. Can't catch up. Yeah, I'm reading. I'm a huge Lisp fan, Common Lisp, which is similar. Oh, so if you're a Lisp fan, you know, I mean, I like all languages. No, I don't. That's a lie. But you must be accustomed to this. There you go. Sorry. That was very rude. But funny at the same time. Whoa! What have I done here? Oh, okay. Yeah. Lisp. So I can get behind that expansion. Same, I did language study in Bachelor and started programming. Yeah. Oh, that's cool. So you started in like Bachelor. Yeah, so I don't have any degrees in computer science or anything like that. I'm literally self-taught. Tried Python and JavaScript, but it felt off when I encountered Haskell. It just made sense. Yeah, that's it. I think the other thing is if you have to think of it also, the way it does things is different, because like what we're explaining now, immutability, the fact that you can't change, values can only ever be a new value. You can't mutate old values. That's in itself, that concept's like, whoa, what's going on? In OO, you can literally just go, I've got a list of something, I'm going to change a third element to whatever, and then there we go, that's fine. Here, the original value would stay the same, and you'd create a new value. So that's a concept that doesn't really exist. I mean, you can enforce it, obviously, in OO, but it's not built in like it is here. So Liz, which of the OSC would recommend to look into? Okay, so you're kind of having a conversation, I think. I felt like Willie, he just changes fundamental structures. Willy-nilly, I like that, yep. And I can't count the amount of times I get a compiler error, which saves me from making doubt myself. Yeah, that's the thing. And the other nice thing, I'm using Doom in Emacs, same as you do. Great minds think alike. So the other thing, what were you just saying then? Amount I get, compiler errors. So this is like, when it's really handy with your compiler errors, would be when you're refactoring. Okay, so you imagine you're at work and you've got business, some business going, I want this new feature. And then you find that new feature means that you've got a function called, I don't know, whatever it does, and you need to change it. Now it needs to accept another input for some reason, okay? And then you change that input. But if you're in JavaScript, and I guess a little bit less more in TypeScript, but still, it won't be as thorough. In Haskell, as soon as that one thing has changed, it'll find every single place in your code that function interacted with, and it'll give you an error. It'll just say to you, this function, my func, my function's called my func, and it will find all the things that are interacted with it. And because the business logic has said refactor this, and it's so helpful in refactoring, you've got like that real good sense that, you're not, basic things like that really get caught easily. Like, now, let's be honest, a lot of people sort of rave and say, oh, well, you don't really need test in Haskell. You still need test, you don't need to be, that like very basic things and, like basic logic and things like that, you're going to be safe. If your code base is going to compile, you're on a good way. You're winning. You know that something's going to run and it's going to be unlikely. But the thing is, any language, you can't custom for edge cases. Edge cases will happen, and you'll need to test for those. So that's basically it. Cool. Feel free to chat. I'll carry on with this because I can't look at everything. So that was that. Right. So yeah, Haskell and functional languages. And I mean, I'll be honest, I've been working now. My first job was in PureScript, and I joined a company, and I was brought in with no experience. And the idea was I was going to learn more and get better. It was a little bit harder due to the circumstance, and the actual business couldn't quite afford to give me the time that I needed. but so I had like quite a hard step into it. But from then on, I've just, I've managed to keep myself in the functional programming languages, and keep working in them. And I'm 100% just self-taught. It's just pure determination. But I just think that I potentially wasted a lot of time, because a lot of content, and it's definitely gotten a lot better, but a lot of content is so, I guess you could say, which is it's a good thing and a bad thing. The good thing is the content's really helpful. It's really terse because the terminology is quite mathematically based. So when you talk about things, they're very specific. You can't confuse, someone saying, I don't know, immutability, okay? So, I mean, that's a really, really simple example. You can't confuse someone saying that with, my functions can't change their state, or, my values must stay the same. So that's really good. But from a beginner's point of view, it's kind of like a bit of a barrier, it's like a, God, I don't want to do this. But things like this, and more people streaming of Haskell, it's like it makes it more approachable because it's a fun language. It is fun, and once I can tell you, once you start getting results from it, it becomes very bloody addictive, and then you end up not wanting to do another language. That sucks, which is good, but it's bad because then you end up missing, like this refactoring. I know that, okay, because you might get an overhead because you have to sort of think about, because you're dealing with a type system, you have to think about your functions and, be a bit more, oh, hi, Jopan, you have to be a bit more, I don't know, like thinking about exactly how things might be structured. It might, essentially, it's going to take you a little bit more time in the setup and getting going, okay? But in the long run, as the basis of a program that's going to be in production and last a long time, when it comes to refactoring and doing anything further down the line, it's going to be a lot easier. And also now there's a lot more content for middle, because what they usually be is very beginners and then advanced, and it's like anyone in the middle, you just got to learn yourself, and the shift is starting to move. So there's more nice. Oh, you're also learning Haskell. Cool. Yeah. I mean, I already know it, but I'm just trying to help people a way to learn Haskell without using loads of maths and like scary words and things that's just gonna go, hell no, I ain't gonna learn this stuff. So yeah, that's the idea. That's what I'm doing. Yeah, cool. Okay, so that's a rant. Let's carry on. Right, so what are we doing? Let's talk a little bit more about list implementation detail. Lists in Haskell are implemented as linked lists or cons lists. Okay, so that was where was I? Like that? Has it opened up down here? Has it? Oh no, I've got to do this thing again. Well, I've got to try and look for it. I think it's called... What is it called? Oh, it's somewhere down here. Where is it? Is it that one? Yeah. Okay, let's do that then. No. Let's do that then. No. Let's do that then. Let's do that. Oh, I've done it again. Okay, yeah, here we go. And then that one, we're going to do that, I know. And that one will go to chapter 2. Cool. Okay, so I'm just bringing up the REPL. Okay, so cons was this. Ooh, no, that's definitely not cons. It was that. So, when I just did cons with 1, 2, 3. Okay, so it'll prepend 1. Okay, so that's a cons. That's an actual function. And we can demonstrate that by doing type, and we'll do cons like that. Boom, there you go. So it takes a single A. There's our single A. Because it's infixed, meaning at the moment you can use it like this, prefix, which is like this. Okay, so you can actually do it like that. 1, 2, 3. There you go. See that one? That doesn't necessarily... I mean, it can... The other way you'll see it sometimes, if things are infix, say like zip, they'll do a bit of that. Okay, because zip normally comes in from the left and then you pass it to two lists. But you can do it like this if you wanted. Oh, hello. Why don't you... There we go. Zip. Going the wrong way around out this. Here we go. Let's do and 3. There we go. That'll work. Oh, I should have put a little space there, but never mind. But in use, you can have it like at the front. Okay, so that's what that means. Oh yeah, sorry. I'll do it. Did we have let's have a look if I have something in my history. There we go. Let's cheat. Boom. Yeah, so I've zipped, and then that's the 2 values. So you can have a function either there, or you can have it in there. Normally surrounded by ticks, but some functions are actually like this because it's a default thing. You can have it be on this side. So it's still saying, this is my first value, this is my second value. Here it is. Cool. So what is it doing? Cons lists. Yes, that's what a cons was. It's a cons list. And because everything in Haskell is immutable, adding an element at the beginning of a list is cheap. Okay, so when we ended up, I kind of was demonstrating that. So when we have like this, so we were going to do, let's have a look. Do I still have it in scope? Not in scope. Okay, let's quickly make it. A equals, so this is what we were demonstrating. 1, 2, 3, 4. Okay, so if we call A, we get 1, 2, 3, 4. Ignore these green bits. They're just warnings. I just tried turning them off, but they're not working. This is our answers down here. Okay, so you see that I've called A, it's in scope, and it's just 1, 2, 3, 4. So now let's do 2. We're going to cons 2 onto A. Okay, and that returns us 2, 1, 2, 3, 4. Okay, so we just literally put the 2 at the front. Okay, but watch it. If we go back to A, it's still exactly the same. It doesn't change. We've not, you can't change the value of A. You can only create new values. So we're always going to take A. You can do whatever you want with A, but you're only going to return a new value. Okay, so it's a new set of, so you can't, so why is that handy? Because it means that if one function ends up changing A, and then the other, so let's say function 1 changes A, and function 2, expects A to be something else, well, it's always going to be the same thing. You can't get A confused. A is going to stay as A. It's not willing to change. Cool. Okay. So for some reason, adding elements to an X and extracting elements from the beginning of a list is much cheaper and faster than working with the end of the list. So where is it? What's faster? Elements from the beginning of a list is much cheaper and faster than working. Yes. So is it going to give you a reason? I can explain why, but let's see if they tell us. In some sense, lists are similar. Okay, I can explain why. Because of the way list works, we demonstrated that they're essentially like that. Okay, boom. You see, so I've just done that. So you imagine if like the compiler's traversing through the things, it's going 1, 2, 3, 4. It's got to get to the end. So it's got to go through all of these to then get to the end. But at the very beginning, it'll just get the beginning one. So this is a lot less expensive than going all the way to the end. I should read the messages, shouldn't I, in case someone's saying something. I don't know about other people, but Haskell makes me learn category theory, and I love that. Yeah, I mean, this is what's great about Haskell. It can be as complex or as easy as you want. And that's the thing with it, you can learn category theory, and you do. But if you try and learn category theory, I don't think of it. I try not to think of it like that. I'm just trying to think. I'm learning a language, and it happens to have these sets of rules in it. Okay, and those rules, by some sort of a miracle, they happen to be related to category theory. Because if you try and think of it as like, I'm just doing category theory, especially if you're dumb like me, you're just going to get overwhelmed and go, oh no, I don't want to know about that. I think but that's what's attractive for me, because I'm doing Haskell, and it's like, well, I'm actually learning something that's potentially like, something else that's not just programming, and, I'm using concepts of like quite heavy mathematics, which, let's be honest, maths is pretty terse in terms of like, it's pretty good at doing things, and calculations. That can't be a bad thing. And I think what I'm trying to do in terms of learning category theory is just letting it trickle in. Just little concepts keep coming in. And I'll admit I'm definitely a lot slower than people, you know, that I know that have started half the time than I have. And they're out there, you know, just saying all crazy stuff about category theory, and I'm still just very basic stuff. So I'd just like to demonstrate that I'm proof that you can be doing production Haskell or pure script, or, you know, a pure functional language, and you don't have to be this wizard of any sort. I could be a wizard. I could start wearing a wizard hat, but it's not gonna happen. Okay, so I guess I spread the Lisp word in here, but there's a lot of Haskell in the air, and it makes it harder to spread efficiency. So hey, yeah, I know, Commander. If you can somehow make Lisp have less of these, you know, then I'm down. Nah, to be honest, I've not really I can't be a judgmental of Lisp because I've not used it in production setting, and I've only really where have I used it? Just in Emacs, really. Yeah, just like doing little things in Emacs. So can you tell me how you change from the prelude to the lambda symbol? It comes built in, but I think you can do H, yeah, which is for help. And I think inside there's a way you do it. I can't remember what it is, let's be honest. Oh, here we go. There it is. Set prompt. And I think you can have that somewhere globally. Set the prompt using GHCI. Yeah, so you end up, and that's where you put your symbol. But fortunately, because I'm on Doom or Doom Emacs, well, it's basically Spacemacs, which is Emacs. It just comes built in, so it gives me like a little lambda symbol. Yeah, I'll give you the lambda symbol. There you go. That's as much as I can help, so I don't want to break mine. Yeah, so that's how you do it, JPAN. You haven't read it? That's the main thing. Oh, so you never really see the brackets. Okay, that's cool. You ignore them. Oh, okay. What, from learning and then you sort of see them? Yeah, sorry. I mean, I think if you Google it, you should be able to, but it's here. If you look at the set arg prompt, here we go, I'll copy that into it as well. But if you do the dash help, if you do this guy, or you can just do H, that'll show you that guy. And then, you know what, let's look it up. I'll help you. I'm here. Oh, no, wait. No, okay, I'll change my mind. I'll help you. No, it's working. Let's do Haskell. Oh, no, I'll zoom in. I keep forgetting that, yeah. I've got like a really wide screen, so you're only seeing a portion of my screen, and it looks fine on mine, but people watching, it's not going to happen. So set prompt globally, I reckon. Globally. Set prompt in Haskell. There we go. And there's your answer. Sweet. Pop it in there for you. Boom. There you go. Have a look at that. That should help you to set your custom prompt. I think that looks like the answer. Yeah. Prelude, set prompt, GHCI. Yes, if you want it globally, look, they've just literally stuck it at the top. Oh no, hold on. Have I got the wrong thing? Oh, I might have given you the wrong thing. I'm sending you like down a wild goose chase here. I just assumed it was right. What else was I set? Prompt. What would you call it? Prompt what? It's like a prompt something, isn't it? Prompt. So look. Yeah, you might have to look because I don't want to sort of spend too much time in case people are waiting to. But it is a prompt. I thought that was it. Maybe it's in options. Maybe it's in options. It'll be one of these. Sorry, you might have to look. I'm just fortunate that it just does it naturally for me. Sorry, buddy. Yeah, but if you find it, post it in the chat. other people might be interested. Okay, so where was I going? In some sense, lists are similar to trains. Let's look at this illustration. Oh, I like a little bit of ASCII, isn't it? That's pretty cool. There's an N then, but I guess it's not meant to be an N. It's like the choo-choo. Okay. Oh, okay, that's pretty cool. Yeah, so that's our chain. Our trains. There's our carriages. So we've done like this, and that. Okay, so that I kind of demonstrated it before, but in case people weren't there, it's essentially, yeah, doing that if you think about it. So this is our first value into cons, and this is our second value into cons, and this is our that. So whatever the result of that would be, like, you know, an X in there, and then it will go, and then that would be appended into there. Okay, so I've done that. So you can see, let's bring this down a little bit. So you can see that adding, oh, you know what? You probably don't even need to look at that. Look at this. I've got more room to play with. So you can see that adding new elements, the railway carriage, well, I mean, they've gone all out on this, haven't they? The docs, the Haskell docs, should just be ASCII elements. That'd be really cool. Then I'd understand it all the time. You can see that adding new elements, railway carriages, these guys. To the left is easy. You just need to connect them to the last element in a chain. Yeah, so this is explaining why things are quicker, like prepending, appending, prepend. Yeah, putting them at the beginning, like cons, because, you know, you're just going, boop, add it at the end, add it at the end, add it at the end. So it's like really cheap. You know, it goes right at the front of the thing. So doing, what were we doing? So doing 4 onto, whoops, 1, like that. That's really quick, you know, because we're literally just going, bang it in. But if we go, what is the prepend? I forgot. Is it just prepend? No. I don't know what's... Oh, here we go. It's working. Is that working? Let me know. I think it should be working. Yeah, I don't know what happened there. I don't know. I didn't change anything. Just decided to die on me. Wicked. Thanks. Literally didn't change anything. I think it's going to be... Oh, no, no, no. Don't do that. Whoo. I need to press cross to cancel it. Oh, hi, by the way. Oh, I need to zoom. I'm so blind. I've got all these chats and things. I can't even read. Helverson. Helverson. Yeah. Well, welcome to the channel. Oh, you're doing a bit of work on a password library. Cool. That sounds interesting. Yeah, so if you want to sort of learn a bit more and you're kind of learning Haskell, it's Danish. I like it. How do you... Oh, I can't ask you to pronounce it, can I? I'm just going to have to guess it. Helverson. Ah, cool. Thanks for the follow. Oh, I'm going to say it wrong again. Helverson. That's probably the worst way, isn't it? Helverson. No, there's probably a much nicer way of saying it. Helverson. Well, I'm called Vincent. You know. Yeah, that's it. Cool. Yeah. Well, join this Slack. It's really cool, and you got the Haskell beginners channel, and in there, yeah, you can literally just look at that. I mean, you know, how does the fmap work? Just like little things. You know, why is this type not that? So you don't have to feel intimidated. It's a good way to go. Let's go back to our trains. Okay, yeah, I've still got some time. Where am I going? Where are my trains? Oh, they're here. There we go. Cool. Choo-choo. So you can't simply attach a new carriage anymore. Oh, hold on. Here we go. Let's go back. You can see that adding new elements, the railway carriages, to the left is easy. You just need to connect them to the last element in a chain. So yeah, the chain is going from right to left. Okay? But imagine how much more difficult. It's okay. You know, we're not all English. And I do spelling mistakes all the time. Much worse than this. It would be to add new carriages to the right. Yeah, I mean, you got to shove it in there. You got to get that one out of the way. You can't simply attach a new carriage anymore. You need to detach the locomotive. Yep, detach this little guy. You know what? We can reenact that. You ready? I don't know. Let's reenact the attaching the locomotive. Yeah, we'll do it from here. Okay. Like that. There we go. Look at that. Magic. Simply attach a new carriage anymore. You need to detach the locomotive. Maybe move the trains around the railway a bit. I'm not going to reenact that. Sorry. And proper position. And only then attach everything back again. The same thing with adding elements to the end of the list. It is a slow and costly process. Yeah. So it's a bit more costly because basically you've got to work. Well, the compiler's good. It's good. Well, it's not going to compile. Sorry. The runtime's going to have to go through. Get all the elements to get to the last one and then pop it in. So whenever you, I mean, it's saying expensive, but it's not expensive like if you're just, if you're going to do last like this one. Whoops. That's not going to be expensive. You can do that. But if you do last, oh, I'm a bit scared. Okay, I'm going to try it. What should we go to? Yeah, well, do you see that? Took a little bit longer, didn't it? Well, don't do that. Let's see how far we can go. Don't know why I'm doing this, but let's do it. Oh my god, should I do that many? I'm doing it. You see, it's taking time. It's taking time. It's going to take too long. What have I done, Vince? Should have done that. But that's a prime example of last taking a long time. Because it's having to go through. Oh my god! Maybe I'll probably break my computer. Am I going to get Stack Overflow? No, stop. I don't know how to stop it inside of here. No, what have I done? Oh no! Kill the whole session. Yeah, goodbye. Yeah, I killed the session. So Let's open a new one. There we go. There we go. We're in. We're back. We're back. It's fine. So yeah, it's costly. It's gonna take because it's got to work through every single value. It's got to work all the way through, and then it can put it. It can grab the last one. It can't just go, oh, this is the end. I'll grab that. So yeah, be careful when you're using last and things like that. So task 3. Let's write our first function to process lists in Haskell. Your first implementation task. Oh, let's move this down a little bit so we can read what's going on. Your first implementation task is to write a function that returns all elements of a list between 2 given positions, inclusive, starting from 0. Okay. Remember that each function returns a new list. Right, so I read that, didn't really understand it, but let's look at an example. Sublist 3, 5. Okay, so it's basically grabbing from 3 and it's stopping at 5. Yeah? Does that make sense? So let's have a look. So, you know, let's quickly print it down here. 1 to 10. 1. I don't know if people weren't here, but when you do that, it generates a list from 1 to 10. Increments in ones. You can make it increment and you can have 1, 3, 12, and it will increment in 2s in this scenario. 1 to 2, 3 to 5, 5 to 7, like that. Okay. So what this is saying up there is if we do this again, 1, 10, like that. Yeah, so it's going from 1 through to 10. It's saying take the number 3. Okay, so 1, 2, 3. Yeah, so from 0. That's what it's saying up here, wasn't it? Starting from 0. So that's 0, 1, 2, 3. So grab the 4th element, and sorry, it's the 3rd element. 0, 1, 2, 3. Yeah. Okay. And then up to 5. So 3, 4, 5. There. So it return us those 3. That's what it's saying. And then if we do like 3 to 0, that's kind of like going backwards. So that's not going to work. You can't go 3 and 0. Yeah. So that's like the rules, I reckon. When implementing, think about various corner cases. You should return an empty list when given numbers are negative. Oh, okay. Well, we'll be able to use, if you didn't follow along, I did do the previous, I think this is part 4 maybe. So there's like another 2 parts. And I think we're going to have to be using some pattern matching and some things like that to get around this. So go look at them. I'll explain it as we go along, but if you want a bit more thorough, go through those guys. Okay, the other guys being the other parts. And also, don't forget to check the data.list module. It is full of a yummy of functions. Is this 335? Is this well, it's not even importing it, is it? Is it import data.list? No. Okay. Or is it? Let's have a look. Data.list. Oh, it is importing it. Just saw. No. Let's have a look then. What should we do? Let's go to the top. That's not the top. This is the top. Let's go down a bit. Let's find it. Up. Right. There. Let's do import data.list. Okay. It's just saying, oh, ensure compatibility with future core libraries. Change the import data is redundant. No, okay. Remove import. Cool. Don't even need it. Oh, I'm in this version of. Let's pretend we do need it. It's just in this version of Haskell, because I'm quite a late-ish version of Haskell, so that's probably why. We were here. There we go. Sublists. Okay, so we want to sort of mess around and try and do that. Well, we've got a pretty good understanding that if we did what do we want to do? Well, we could take, okay, so we know if we do take a number, so let's have a look at our number. So if we do take 3, let's see if that, let's do this. So take 3, and then our list is 1, woo, to 10. Uh-oh, not 100, 1 to 10. Okay, and that returns 1, 2, 3. Okay, so that's not quite what we want. Let's try a drop then. And let's use, we'll use, yeah, drop 3. Okay. So 1 to 10. Cool, okay. That looks a bit more like it, doesn't it? So we know we need to do a drop to start off with, because that's going to drop the first elements. In our case is 3. So let's try again. Yeah, so it's going to drop the first 3 elements, which is what we want to get. So you look at the results. Okay, so that's cool. Drop the first 3 elements. And then we want it to do to 5. So then drop 3 to 5. So how are we going to get, well, obviously, because if we do take, I'm going to do that shortcut again. So if we do like this, if we do 5, whoops, 5 minus, not minus, 3. And then what have we got? We've got 4 to 10. Oh, not quite, not quite. Because look, if we do 5 minus, because I was thinking, well, we can do 5 minus 3. But obviously it's 0. It starts from 0. So technically, if we to do, you know, because it's 0 delimited, we could go 3 plus 1. Cool, and that returns us the right thing. Yeah? Does that make sense? Well, I've just played around in here, but let's put it out in here. And what we'll do first is, it said, look, you've got to be careful with some things. Where was it? Where was it? Oh, hold on here. Yeah, no, it'll still work. It'll still work. You should return an empty list with given numbers when given numbers are negative. So if any of these are negative, cool, we can do that. So we know that we've got an A and a B. Okay, so that's like our int and our int, and we've just called them A and B. Actually, let's call them X and Y, so we don't get confused with the ones above. Okay, and then we're saying here that we take 2 integers, a list of something, and we're going to return us another list of something. Okay, so that makes sense, doesn't it? So let's do that. Now we're going to do some pattern matching. So let's do... What should we do? What should we do? Which way should we go with this? Because we want to check if that's true. Yeah, let's do it like this. Let's do a guard. Okay, so it was like equals. Is it like that? I forgot. I'm going to do it anyway. If x is lower than 0 and y is lower than 0, then return us an empty. So look, is it complaining? No, it's happy. Cool. So that's that. Yeah, so that's that part. So, right, I'll explain it. This is in the last chapter, but I'll explain what it's doing. Here, we've basically got these values, and we're using a guard, which is like this big bit here. I should ask, is the music too loud? Maybe it is a little bit loud. I'll turn it down a little bit. I think it's this song. It's Mozart, Piano Sonato, number 11, A major. What was the answer? Oh, music's fine. Okay, cool. Because, yeah, my monitoring it just doesn't give me proper monitoring, the OBS. So I've basically got to look at some really small little things and hope that it gives me the right, I'm seeing the right amounts. Anyway, so guards. So you can do a function and x and y are that one and that one. X, y. And then equals. And then within the body, we're using a pipe. Yeah, so it's like the straight up symbol. And we're seeing, is x lower than 0? Okay, so that let's pretend that we're doing -1. well, that'd be false. Okay, and then if we go here, so as long as this is essentially checking, you know, it's trues. Anything before here is a bool. Okay, you can only do bool values, things to check before you carry on to the body of the function. So here we're saying, and this and, if we go look at it, I think it's usually an and in most languages. I think it's the same thing. I'm trying to think. There we go. So it just takes 2 bools. So we can go like, whoa, don't spell true like that. True. And false. Yeah, that's false. False and true. False. And then true and true. True. And true. That returns true. So if either side is false, then it won't reach into here. Okay, but if both sides are true, I should have done and, should I? Should have done or. Because we don't want both of them to be false. You know, it's if either of them are false, that's gonna be dangerous. I mean, yeah, as dangerous as do. Yeah, same thing. So we can do true or true. That's true. So they both have to be true. So yeah, so if they're... Oh, hold on. Have I got it right? Let's have a look. So... Yeah, that works. So it's only if both are false. It's the opposite way around, isn't it? To and. There we go. Then it's false. So basically what it's saying, is that lower? Yes, it is. So that's true. Is that lower? No, it's not. So then that'd be true and false. Hold on, let me think. True and false returns true. Oh, we don't want that. We definitely don't want that. Because then that would go... Oh, no, we do want that. Look at me, getting all confused. What am I doing? God, so, yeah. Okay. Yeah, so if any of these return true, which is what we want. So if any are below 0, which is a minus, then we're just going to return empty. Yeah? That's what it said up here, didn't it? Let's have a look. When implementing, think of the corner case. If you should return an empty list when given numbers are negative. So here we're doing, we're doing a check if they're below 0. So if that or that is lower, return us an empty list. Okay. And then you can do any other equality checks. But what we'll do is we can use a keyword. Otherwise. Okay, so we've just done like our equality test to go, okay, well, you know, is this any different? Otherwise, we want to start doing our things. We've got 2 numbers then. So then we've got access to X and Y. Yeah? So let's have a look. Look, here we go. I'll start showing some... oh, it's not doing it. Let's have a little look. Let me just do some of that. Yep. Do some of that. I'm just waiting for it to compile quickly. There we go. We've got... Where's the error? Yeah, I did it wrong. That's probably why. That's fine. That's right. What's wrong here? Expected. Could match type A to... Oh! Goodness. Yeah. X, Y, Z. Yeah, because we need... This is our list. If you see... You'll see sometimes that... this is a cool thing, you know. Actually, I could call it... No, we'll just keep it like that. If you see an S at the end, it's probably because it's plural. You know, so you think Zs. So there's an X, Y, and some Zs. Yeah, so I've got my X, my Y, and this is some Zs. Cool, so we're only utilizing X and Y. Okay? And then we return that. Now I've used a type hole, which is just an underscore. Let's read our error. I'm just opening it up a little bit. Where's our error? So we found a hole, and the hole it wants to return us is A. Yes, you see it's a list of A, and whatever the A happens to be. So we don't know. You know, it could be anything. So, and then below, if I open up a little bit bigger, It will tell us relevant bindings. So this is what we've got in scope. Let's move this up a little bit so we can see it. Okay, so it's saying that ZS, Zs, and that's it. See, this is where like the compiler is really handy. Kind of like gives you all the information that you need. So you know that Zs is a list of A's, a Y is an int, and an X is an int. Okay, and it says, well, if you want, these are all the valid things you can use. You can just use Zs because technically, if we look at the type, Zs is a list of A's. So you know, technically, to pass what we're saying our type is, we could just return a list of A's. But it wouldn't make the function work. So we'll do that. So now what we'll do is we'll do a where clause. Let's see what we call it. We'll what should we call it? We'll just call it fun1. What's fun1 going to take? Fun1's going to take our. We had it in here, didn't we? Let me just. Oh, don't do that. Let me just. Let's go down here. Let's go down there. No, don't. Just go down here. There we go. Go away. And then we've got to find this other one, which is that one, I think. Yeah, here we go. We're back. We're back. Okay, so we had it up here. What we were going to do? Yeah, there we go. So we've got a take and a drop. So we can put them in line. So the take, let's have a look. I think the drop came first, didn't it? And the drop was going to take the 3. So if we look up here, a 3 is our first number, so it's going to be our x. Okay, so we know that we're going to do fun x. Okay, so that's the first thing we're going to run. And then the result of that, so we're going to have a new list now. Okay, and then we're going to do fun2. Oh, hold on. We want it to do that. Whoops. So, I could just inline it. I was going to put it in a where clause. Okay, but let's have a look. I'll put it in a where clause after. And drop. Set as a 1. Drop 3. We showed drop 3. Hold on, we're going to do. It's the other way around. It's drop like that. Drop, and then this side, take. Yeah, and then we're going to do. Yeah, it's going to do x minus y plus 1. I think that's going to be the idea. Oh, take, yeah, drop z's. There, should be happy. What do you think? I got it right? We just don't know, do we? But what we'll do is I'll demonstrate the where clause in case you've not seen it before. We could do where, and we'll do fun1. Okay, I won't give it a type declaration, but you can do. Actually, let's do it. It's a good habit. You know, think of your future self. That's what they say, isn't it? Especially when you name it the wrong function. So fun1 will take an integer. It will take a list of A, and it will return us a list of A. Okay, and then we're literally just doing. We're gonna have to think of some. No, we've got to name something different. Buzz. Okay, so then we're just doing drop. Drop. I mean, yeah, it's not really worth, but I'm going to do it just to show because, you know. Okay, so that's that one. So if we want fun1, we can replace fun1 with drop. We've just basically created drop. We can show also. Shall I show it now? Yeah, I'll show you a nifty little trick. Ready? At the beginning of the tutorial, it's called Eta Reduction. Look at this. Boom, that still works. So it automatically puts them at the end of this function. It knows that takes 2 functions, and it knows. But watch this. If you do it like that, it doesn't work anymore because you've declared them on the left. But if it does like that, it works. We'll explain that in the future. Okay. So that's fun1, and then This is that. I'm not going to split it up. It's a bit silly, isn't it? I should have just left it. Drop and take. But yeah, anyway, you can do that. And then you can use it above. So that's what a where clause is. It basically means you can create functions underneath. And you can grab those functions and use them there. But we won't. So, let's go in here. What's the time? Oh, I'm probably gonna call it a day after this one. Yeah, because I've got to stop. Sub. I mean, I could carry on, but I'm sorry. I've got to have food. I'm hungry. So what was their example? 3, 5, and we're going to use 1 to 10. Come on. Don't do that. Look what I've done. What have I done? I need to reload, which is that. So we're reloading our REPL, which has got all the content inside. And then we're doing this. Sublist. It's not in scope. Okay, we can make it in scope. Is it chapter 2? Yeah, I'm just importing chapter 2. And then I'll do that. Sweet. That's worked well, hasn't it? Why has it worked well? Is x lower than 0? False. Is x... Vince, what have you done? Fluh. Yeah, that's still false. What's wrong with you? You should have done that. Sublist 3.5 is returned as an empty. What have we got wrong? Let's have a look. Let's try and work it out. So that was 3. That was 5. Boop, 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 boop. Yeah, was it 3 and 5? Yeah, 3, 5. And then here was 3 again. And then that was our 1, 2, 10. Okay, well that's where I got it wrong. I've done it the wrong way around, haven't I? I guess. That'd probably be the issue. You'd assume, wouldn't you? Let's try that. Oh. No. Let's just do it in here first. Oh, it's going to be quicker to just do it like this. Oh. Am I still in there? Sub. V. Hello? No? Ah. Why are you doing that to me? No! I've lost it. It's because I'm trying to rush to finish. Okay, get to the bottom. Bottom. Oh my goodness. No, see, it wasn't wrong. What have I done? What have I done? X. Oh, the wrong way around. Y. X. Take. Drop. There you go. Did have it. I just didn't do those the right way around. I think. Let's have a look. Reload. Let's do that. Cool. It worked. Yeah. Does that make sense? Okay. I'll go through it just slowly. So we know our values. Let's do it like this. Okay. So we've got X, Y, and Z. Okay. So let's just do here. Comment like that. So our X is a 3. Okay. Let's do it equal. R3. Y is equal to 5. Yep. And then don't do it there. Do it here. And that is 1 to 10. Okay. So let's have a look what's happened. So we check if anything's below 0. So if anything's negative, and if it is, we return just an empty list. Otherwise, we're going to do the first thing. We'll go from the right hand side because that's the first thing will get worked out. So we'll drop X is 3. So let's do it in here. Drop X, which is 3, and that's going to be 1 to 10. Okay, so that returns us that. So if you look at 1 to 10, it's dropped the first 3 elements. So we've got this now. Okay, and then now we're going to take... Whoa, it's gone there. We're going to take... so we were doing y, which was 5. So if we look here, y is 5. 5. And we're going to do minus x, which was 3. But then because it's 0 delimited, or we're going from the number 0, we've got to add 1. Because lists don't work from 0 in Haskell. They'll go from 1. Yeah. So take that. We're going to pop that in. And then that returns us 4, 5, 6, which is exactly what it's looking for. 4, 5, 6. So now let's try it with this. That should return us an empty. Yeah. Oh, let's see. What's this going to return? Whoo, that worked. Phew. Cool. Okay. Yeah, I think I'm going to stop there then. What? Yeah, because then we've got another thing and we'll carry on. Maybe if I get time, I might do it tomorrow. Yeah, if I do, it'll probably be like 7 o'clock, and I'll just do another 2-hour one again. Yeah, I'll put it on my Twitter and stuff, or wherever. I'll just add it. Yeah, cool. Well, thanks for coming, and yeah, hopefully see everyone soon. Okay, cool. See you later.